Okay, so now with it clamped together more tightly, let's turn it back on and see if it still makes a loud noise. So the transformer is still making quite a loud hum, however it's very reduced from what it was before. Now the real glory of this transformer is found through its high current output. And so taking this old nail, we're going to pump through it a bunch of current. And to figure out exactly how much current, I'm going to be using this clip-on amp meter. Okay, with that all positioned up, let's go ahead and turn it on and see what happens. And if we take a look at the amp meter here, we can see that we maxed out at around 940 amps. Now the wires are still fine and everything, except for that it got so hot so fast that it melted straight through that terminal lug. Using Ohm's law, since the voltage is only going to be around 2.1 volts. Now the resistance of human skin can vary anywhere between 1,000 ohms to 100,000 ohms. Basically, this number varies quite a bit based on where you are and how hydrated you are. So in a worst case scenario, you can see that the current that would be going through your body would be about 2.1 over 1,000. This in itself is far below the lethal limit, and more likely your skin is going to be somewhere in the middle here. So basically, the amount of current that is going to be flowing through you should be so low that it won't affect you very much. So on a side note, hopefully this will help to dispel that myth that current is what kills you and not voltage. Because you see, the voltage sort of acts like the source that allows more current to flow through a bigger resistance. Now as for transformers, a good formula to remember is going to be this. The voltage of the secondary divided by the voltage of the primary is going to be equal to the number of turns on the secondary coil divided by the number of turns on the primary coil. So basically, applying this to our transformer we had, on the secondary coil we're getting about 2.1 volts, and the amount of voltage going in was about 120 volts. And so if we set this equal to the number of turns on the secondary, which was about 2, we can then calculate the number of turns on the primary. Solving for the number of turns on the primary, we'd get somewhere around 114.2 turns. And so using this formula, you can design your very own transformers in order to get a desired voltage. Now one last thing, the power in watts is going to be equal to voltage times current. So the current that we maxed out at was around 900 amps. So if we have 900 amps times around 2.1, we can see that the amount of power running through that secondary coil was around 1,890 watts. If we were to measure the amount of power in watts going through the primary coil, we'd see that it'd be slightly more than this. This is because the transformer is not 100% efficient. So next I'm going to touch these two wire terminals while it's turned on, and you'll see that nothing will happen to me. And so as you can see, when it was turned on, touching these two terminals didn't really do anything. Now don't hate me too much, because this is more just to poke fun at the trends of the internet. So I'm going to take this knife and I'm going to put it in between these two terminals. Well, we got a sort of glowing red knife. So now you know some of the principles behind a transformer works and how you can make your very own high current transformer. Thank you all so much for watching the video. I know my projects haven't been unique lately, and that's just because I've been a little bit busy with college applications and such. Also, this shed has no heating, and it's been pretty cold in here. But anyways, things should be returning to more Zellius projects pretty soon. And speaking of which, if you have an idea for a project you want me to try, go ahead and let me know in the comments, and I'll try to get to it. Anyways, if you learned something new in this video, I'd really appreciate it if you'd leave a thumbs up. And if you'd like to see my weekly science videos, go and hit the subscribe button so they'll show up in your subscription newsfeed. That's all for today, guys, so please remember to be safe. And have a wonderful day. So I should start off by saying that I'm not the only YouTuber who has done this. In fact, there are many videos on how to transform a microwave oven transformer into a high current output transformer. However, this video comes from the many requests I got to do this. And if you're new to electronics, hopefully I'll be able to teach you a few new formulas along the way.